Hello and welcome. In this video, we're going to take a look at another method for solving a quadratic equation called completing the square. Now, if you already are familiar with the quadratic formula, you may not think that there's any other method that you need for solving quadratic equations. But it's actually completing the square that gave rise to the quadratic formula in the first place. And when we take a look at quadratic functions later on, and maybe we're trying to look at graphing a bit more, completing the square is going to be useful for that too. So let's take a look at the steps. There's sort of 6 steps here that we might want to take a look at. And step 1 is to make sure that you've got a quadratic equation already in a standard form. For instance, 4x squared plus 12x plus 9 equals 0. And if you don't have equals 0, you can move some terms around so that you have it in this nice standard form. Now, if the coefficient a is not equal to 1, factor it out of the x squared and x terms. Now, by factoring the 4 out of the x squared and x terms, I end up with x squared plus 3x in the brackets. Luckily, in my case, 4 went evenly into 12. But if it doesn't, then don't worry. You can always just have a fraction there of having the coefficient b over 4 when you divide by 4. Now the next step is maybe the confusing part. We need to add and subtract the square of half the coefficient of x. Oof, okay, what is that? The coefficient of x here is now 3. We need to take the square of half of that value. So the square of 3 halves ends up becoming 9 over 4. We add and subtract. Okay, we're allowed to do that because if you add a value and then subtract a value, you haven't altered the overall value of it in any way. So plus 9 over 4 minus 9 over 4 is completely allowed. It still ends up resulting in 0. Okay, if you factored a out, distribute it to the negative term. Great, so let's take that 4 and distribute it just onto the negative one. We're going to pull that term out. That leaves us with 4x squared plus 3x plus 9 over 4. Factoring out the negative 9 over 4, or pulling that out and multiplying by 4, distributing that ends up becoming negative 9. Well, that's kind of handy. It actually ends up also having a plus 9 at the end here. Those two things are actually going to cancel each other out. Now, you can start collecting like terms here if you like. Negative 9 and 9 can be added together, but that's not always going to cancel out. Just keep that in mind. These two terms should just get collected together and they may end up with any number, any real number. But collecting those together, and in our case, it just equals 0. Now, next part is completing the square using a special product formula. Once you've done this, you should end up with something of the form a plus b all squared, or a minus b all squared. Square double product square. So this last value here, 9 over 4, if you think about that as being capital B squared, then our case would be capital B would be 3 halves. And at the beginning here we have x squared. That would be like the a squared, and so that would just be x. And then the middle term here is going to be double the product, which is double of 3 halves. So it does actually match up perfectly with this form. You can double check by foiling that back out again, and it does in fact end up becoming x squared plus 3x plus 9 over 4. Now, you've written it out in this new format for a special reason. You try to isolate the square and then square root both sides. In my case, I can divide both sides by 4, and that cancels out the 4's here. 0 divided by 4 is still 0. Now I've isolated the square, and then I'm going to square root both sides. Now remember, when you square root both sides, you have to consider positive or negative values. Now in my case, taking the root of 0 is 0. Plus 0 and minus 0 are both 0. I get a single value here. And now I have x plus 3 halves equals 0. And that means that x is going to equal negative 3 over 2. I can isolate it. Only one solution in this case. So that's pretty unique. Remember that quadratic equations either have 2 solutions, 1 solution, or 0 solutions. In my case, I only get a single solution. but you can try this out in general. And in fact, if you use the standard equation, you just leave things with A's, B's, and C's, and you go through all of these steps, you will, on your own, just discover the quadratic formula. That's where it's going to come from. At the very end of this, you will end up with negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Maybe you should try that out. You'll actually understand exactly where the quadratic formula comes from. So remember that this is kind of like a special case. I've just done one example of it. It's probably best that you try this on your own to be able to understand how completing the square works in general. But I think we'll probably end up rediscovering this again later on when we look at quadratic functions and graphing them in a sort of a standard form. I'll save that for later. That's it for now, and thanks for watching.